see a relationship of what happened if we multiplied on the inside of the parentheses where the log was, or if we divided. Now we're going to move down to look and see what would happen if we were squaring, cubing, raising to the fourth power, etc. So in order to do that, we are going to use our calculator, and we're going to evaluate the log of 25. So the log of 25 is 1.4. That's what we should get. So what it wants us to remember is that the log of 5 is 0.7. So how can we get from 0.7 to 1.4? What is the relationship between them? Well, maybe you recognize that this is really 1.4 is 0.7 plus 0.7, or is 2 times 0.7. Those are the same. So let's go on to the next one. 5 cubed is the log of 125. So if we were to take log of 125 on our calculator, we'd get 2.1. So how can we get 2.1 from the 0.7? Well, it looks like I'm just adding another 0.7, or 0.7 plus 0.7 plus 0.7, which is equivalent to 3 times 0.7. 5 to the fourth is the same as saying log of 625. So if we were to take the log of 625, we would get 2.8. So it really looks like we could take 4 times 0.7. And if you check that, it is 2.8. So now that we see something, you'll notice when we had this number squared, we multiplied the log of 5 by 2. When it was log of 5 cubed, we multiplied the log of 5 times 3. When it was the log of 5 to the fourth, we multiplied the log of 5 times 4. So we would think probably this time that if we had the log of 5 to the fifth power, we would want to take the power and times it by the log of 5. So 5 times 0.7 is going to be 3.5. Now let's check and see if our thoughts were right. If I took 5 to the fifth power, I get 3,125. So if I take the log of 3,125, I'm going to get 3.5, which is correct. So it looks like here I should take 6 times 0.7, which would be 4.2. And if I was to take the log of 15,625, I do get 4.2. So what we're noticing when we're looking at a pattern is, if we're looking for the pattern that we see at the table, whenever we have a power inside here, we should multiply the log of the base by the power. So that's what I think is happening. We're going to multiply the log of the base by its power, or by the exponent. So what we've done here is we've kind of developed some of the major properties of logarithms. And these are what I call the big three properties of logarithms. And so we're going to spend some time investigating those, or writing down what those properties say. So here are our properties of logarithms. And so we want to get them down. The first property is what we call the product property. And the product property says log base b of x times y is the same as log base b of x plus log base b of y. Log base b of x plus log base b of y. So it says here the log of a product is the same as the sum of the logs of the numbers. So this is basically what we were saying a minute ago. Multiplication inside a logarithm changes to addition on the outside. And so that property is what we call our product property. Our next property is what we call the quotient property. And we've had properties, product properties, quotient properties of exponents, but now these are our properties of logarithms that we have to be familiar with. So if you look back at the patterns that we established, it looked like when we divided on the inside that we really subtracted. So this is going to really become log base b of x minus log base b of y. So the log of a quotient is the same as the difference of the logs of the numbers. So division inside a logarithm changes to subtraction outside. Division inside the logarithm changes to subtraction on the outside. The next thing we have is what we call the power property, where we had the power on the inside. And what we found by looking at our examples is that when we had the power on the inside, we took the power and we multiplied it by log of the number. So the log of a number raised to a power is the same as the product of the power and the log of the number. It's the same as the product of the power times the log of the number. So a power inside a logarithm changes to multiplication on the outside. Now these properties right here, these three properties, the product property, the quotient property, the power property, those properties are really important when we're studying and working with logarithms. These are so important. I call these the big three properties. You cannot get by in the world of logarithms without knowing these big three properties. You have to know them. So you've got to know that if you see multiplication inside, that means addition on the outside. If you see division on the inside, that means subtraction on the outside of the numbers. And if you see a power on the inside, that is a product. Okay? Now we have a couple of smaller properties down here that we also would benefit by knowing. This first property, these are just what we call inverse properties. But you'll notice here, if I have the base of the logarithm is same as the base of the exponent, what's going to happen is basically they undo each other. Log base b cancels out a base b and leaves us with p. So if the log of the base is the same as the base of the exponent in your argument, that's what we call that number inside that logarithm parentheses, you just cancel and get the base, or excuse me, get the power. So here we have log base 2 of 2 to the 6. Well, look what happened. Base 2 cancels out 2, and you're just left with the fact that x is equal to 6. It works the same here. If it just says log base b of b, what's the power understood to be on that b? That power is understood to be 1. So log base b cancels out base b and leaves you 1. So here it is, log base 2 of 2, log base 2 cancels out base 2, leaves you the power, which is 1. And these are what we call our inverse properties. So all of these properties are going to go together and become really important in our work with solving logarithmic equations, which we're going to get to later on in this chapter, and being able to work with them. So these properties you really need to be aware of. Okay? So make sure you've got that written down, and I'm going to move to the next section of the notes.